Hello, my name is S-EL0. I'm a software engineer at ARM as part of the open source group. And I'm presenting the secure partition management in Opti, and that's specifically for the pre-8.4 Cortex-A devices. So maybe a quick start about what FF-A is. FF-A stands for the Firmware Framework for ARMv8. It defines a set of concepts and APIs for handling secure partitions. It has two main components. It has the secure partition manager dispatcher, the SBMD, which runs into S-EL0 as part of the trusted firmware A. And it is responsible for routing FF-A messages from the normal world, between the normal world and the sbmc. Then there is the sbmc, which stands for the Secure Partition Manager Core. This can run into Secure EL0, Secure EL1, Secure EL2, and Secure EL3. This is responsible for managing secure partitions. So it is responsible for loading them, it's responsible for sending messages to them back and forward, and all that kind of stuff. So this is kind of an overview of how the FF-A stack looks for 8.4 devices. So on the left, we have the normal world with kind of standard use-based application, EL0, EL1, standard kernel. EL2 can be done in hypervisor on top of that. And between the kernel and the hypervisor, the FF-A is already being used to kind of pass the messages. And then from there, it goes to the SBMD, which runs into TFA. That already runs in the secure world in Secure EL3. And then normally, if you run on normal devices which have the secure virtualization extension, there is a secure hypervisor that can run in Secure EL2. This is not supported for pre-8.4 devices. We don't support the secure virtualization extensions. So that's why the SBMC needs to run into Secure EL1. The current implementation that we're working on has the SBMC running into Opti. And then we have the secure partitions running in Secure EL0. They can also sometimes run in Secure EL1, but mainly they're supposed to run in Secure EL0. Next slide, please. So back to a little bit more overview of what the SBMC is. So like I said, it's the Secure Partition Manager Core. Its main responsibilities for managing the secure partitions. We are using the Opti as the standard SBMC implementation for pre-8.4 Cortex-A devices. Most of the secure partitions will be run in Secure EL0. To ensure that we still have isolation between the different SPs without the use of a secure hypervisor. And the current implementation we're looking at is based on the FF-A spec 1.0. Yeah, slide. So if we're looking at some of the core responsibilities for the SBMC, so one of the core responsibilities is basically loading and managing SPs. So the SPs needs to be loaded, the context needs to be set up, and we need to do context switches between SPs. Then there's the manifest data handling. So for the FF-A spec defines a manifest files which define some of the information for a secure partition. So they can be the endpoint ID. It can be some of the memory that needs to be mapped. It can be interrupts. It can be device region, all of that stuff. So this is all stuff that the SBMC is responsible for to handling that data. So it needs to map the memory. It needs to set the interrupt correctly and that kind of stuff. Then it needs to manage the endpoint ID. So every secure partition has an endpoint ID. So it has to make sure that all the endpoint IDs are there. It also has to be sure that it also has to make aware that the SBMC can kind of respond the proper endpoint for UIDs by there is a specific FF-A method for requesting all of the endpoints. Then one of the main responsibility is the interpartition communication. So SPs have to be able to communicate between each other and also between secure partition and the normal world. So this is the send direct request and the send direct response. So the SBMC has to make sure that the FF-A messages are forwarded to the correct secure partition, and also kind of when there is a chain of multiple SPs, that the response are also end up to the correct SP, and that we don't break the chain. It's also, SBMC is also responsible for the RxDX buffer handling. So when an endpoint, which can be a secure partition or the normal one, needs to kind of communicate with SBMC, where it needs more data than it can handle by the normal FF-A arguments, which are the X0, X2, X7, then it can use an RTX-DX buffer for kind of moving more data. And for that to be able to work, there is some FF-A commands which kind of map the buffer, so it passes the RTX buffer, and it manages kind of handling these stuff. So that's also something that the SBMC is responsible for. The secure partitions are also able to share memory between each other. So there is a fair amount of FF-A messages which are for memory sharing. So it's it's like memory share and memory request and memory cleaners and stuff like that, which is there for SCPs to share memory between each other, or for the normal world to share memory regions with the secure partitions. So the SBMC has to be aware that kind of these regions are mapped properly, that they're only mapped with the SPs that are that have access to it, and all that kind of stuff. And then another aspect of the SBMC is that it has to do some kind of device management. As part of the manifest file, we can map some interrupts to an SP and also some memory regions. So the SBMC needs to make sure that these SBMCs are properly set up, that when interrupt is triggered, that it's being passed to the proper secure partitions. And then when the secure partition is done, that the access is given back to whoever was interrupted. For the device region, you can also kind of request device region memory. For that, the SBMC basically has to kind of map the regions in a similar way as for memory region, but then with specifically device-specific options without like caching shouldn't be enabled and all that kind of stuff. Next slide, please. So if we look at the secure partitions and the trusted application in Opti, both of them are kind of secure executions environment that run mostly in secure L0. There is, however, a fair amount of difference that is important to know kind of how the SPs works and how some of the implementation is done. So if you look at trusted applications, so they always have a clean context for each invocation. So that means like every time you send a message to a trusted application, it's always started from like a clean slate, which means that if you have any kind of user data that needs to be stored between requests, it needs to store it in kind of the TA session. Secure partitions, on the other hand, they're always kept into memory. So they're loaded at the beginning of boot, and then they're kept into memory. All the data on the stack, on the heap, it's all kind of there. And it's all there between invocations. Trusted applications can be dynamically loaded during runtime, so you can load a trusted application from Linux. It can be, for example, loaded into the secure world and then can be loaded like that. For secure partitions on the other end, all SPs at the moment are loaded during the Opti initialization. Trusted applications have multiple endpoints and they all run to completion. So it's basically like calling a function, and then when it's done, the function, it returns back to where it was. Where secure partition have one entry point. So that entry point is called at initialization. And then from there, we basically have a while loop where we kind of constantly run the same application. And then it might be interrupted from there, but once we go back into the secure partition, it kind of re-goes from where it was interrupted. And the same is when it does a syscall. So if it's a syscall, then it might be interrupted, but then afterwards it will continue at the same place where it has been interrupted and where it did the syscall. So trusted applications can have multiple sessions. At the moment, secure partition, you can only have like one instance of a secure partition running. And then, so it means if you need to track multiple requests from different requests in a secure partition, this has to be done by the implementation itself. Trusted applications use optsyscall to communicate with the outside worlds, while in the secure partitions, we prefer to use the FF-A messages to communicate with the outside world. We are looking into kind of creating a mapping between the global platform messages and FF-A messages, so that there will be a mapping between the two, so that hopefully people can just get by only using the FF-A messages. For trusted application, there is the libsp, which exports the syscalls to the trusted applications. We introduced the libsp, which kind of does the same thing, where we expose the FF-A functionality to the secure partitions. Yeah. Next slide, please. So if we're looking kind of the context of the secure partitions, kind of the data that we need to keep for a secure partition, the secure partitions and the trusted applications, they have a lot of kind of data that is the same, and also a lot of functionality is the same. That's why we introduced kind of a trusted service abstraction layer, and the trusted service abstraction layer basically combines the trusted applications and the secure partition functionality. So this makes it for us possible to use the standard opti functionality to load the SPs, to use the memory management, use LDL, and also for the SVC handling, to use kind of the same principles that are being done in the trusted applications at the moment. We do use internally SP sessions, like the same as TA sessions. The only difference is that we only have one SP sessions for each secure partitions. We do this kind of to make it easier for us to use the internal opti functionality, kind of like, again, for the mappings and all that stuff. We use the SP sessions and the SP context for to store our SP specific data. Like I said, normally the sessions are created at initialization, and they're created there's only one session always, and that's kept into memory, and then normally, yeah, that's never deleted normally. Well, another thing that we do is in the SPs is that we kind of store all of the registers and the context in the SP regs of the secure partition context, to make sure that we can kind of do context switches, and that we can stop an SP and then restore it later. And then there is the open SP sessions linked list, which tracks all the SPs. Yeah, next slide, please. So the initializations of the secure partition is fairly similar to the early TA process. So what we do is we load the SPs at the last step in the initialization process. At the moment, we also embed it in the optimage, and it's very similar to the early TA. How early TAs works. We store them in an SP store, and you can add them to the build by using, in the upstream version, there is the SP path, but in the proof of concept version, it's still the early TAs that you need. We also use LDL to load the SPs the same way as normal TAs are done. We are kind of developing some patches where hopefully we can use BL2 to load the secure partitions. And then BL2 would pass a manifest file or a device tree to Opti, and then from there, Opti knows where the secure partitions are loaded. Yeah, next slide, please. If we look at some of the implementation, there is basically two main components in the Opti kernel that handles the SBMC. First of all, there is the thread SBMC. This is for this handles all the messages that are coming from the non-secure world. It also handles all the messages that kind of where Opti is designed as an endpoint. So Opti can also be a secure endpoint. Once we receive a direct request in the thread SBMC that is meant for a secure partition, we switch to the SBMC SP handler, and this is kind of the second big part. This is meant for handling all of the FF-A messages from the SPs. It always runs in a thread context to make sure that we have a big enough stack, but that we can also access some of the functionality that you can only access running on a thread. And then from there, it calls sbenter, which is used to kind of start the SP and jump back into the SP context. Yeah, next slide. Yeah, this is kind of a flow chart of how it goes. Basically, when there's a direct request going from the non-secure world, it's being sent to the SBMD. From there, it's sent to via an ERET from SecureL3 to the SecureL1, and in opti we get to the thread SBMC. From there, we forward it to the SBMC SP handler. Once we get in there, we basically have a loop there where we check the FF-A messages. And then, for example, if we have a direct request, what will happen then? It's we will copy the FF-A messages into the secure partition context. So the context of the specific secure partitions. So the FF-A A0 to A7, sorry, is copied into the X0 to X7 registers of the secure partitions. And then we basically jump into the secure partition where it left off. And that's basically how we copy the FF-A messages coming from the normal world or coming from another secure partitions to the secure partition. And then once the secure partition is done, it will send another FF-A message, which is always done via SVC. The SVC handler will basically store the context. We jump back into SEL1 where we left off. And then before going back into the while loop, while we check the new FF-A message, the X0 to X7 parameters are copied back into the FF-A message. And that's kind of how we then receive the FF-A message from a secure partition, and then we handle it again. And then once we have a message that is meant for the normal world, we just pass it back to the SBMD, and from there back to the normal world. Yeah, next slide, please. So yeah, for like the context switching and the entering, exiting the SPs, we have a function called sbenter, and that's basically used to kind of restore and continue the SP executions. So we copy the FF-A arguments on into the SP execution context. So the A0 to A7 is copied into X0 to X7 of the secure partition context. And then we call the enter invoke command, and that just basically works the same as kind of trusted applications works, where we kind of just restore the context and then jump into secure EL0. And then to leave a secure partition, there is the SP handle SV, which is the SVC handler. There we only we only kind of store the SP context. Afterwards, we return back to SEL0. And then at the end of SP enter, we copy the FF-A arguments from the SPCat SP context. And then we jump back into the sbmc SP handler, and that one kind of handles then the message that we got from the secure partition. Yeah, next slide, please. So we created the libsp, which is used for building secure partitions. So it builds kind of the basic framework to build secure partition. It exports all of the function that makes it a little bit easier, that you don't have to write your own SVC calls, but it exports the SVC calls so that people can easily use it. So like I said, it exports all the FF-A messages. And at the moment, it's part of the Trusted Services project, and the link is there to the Trusted Services project. Yeah, and then there's also a fair amount of secure partitions that you can find in the Trusted Service project, which can be easily used as some kind of reference to start kind of creating your own secure partition. Next slide, please. So opti itself can also be used as a secure partition, so that opti will become the endpoint. This is used to wrap opti-specific calls into FF-A messages. So when the SBMD when trusted firmware runs with as configured as SBMD, it only kind of passes the FF-A messages back and forward between the normal world and the secure world. and to be able to still use OptiSys-specific messages and to be able to use the trusted applications, there is a way to encapsulate the messages are being encapsulated in FF-A messages. So the Opti messages are being encapsulated into FF-A messages. And then when a direct request message is received by the sbmc, which is specific for Opti, it will kind of unwrap that messages and pass it back and then handle it kind of as a normal Opti messages, and then it can send it back to trusted applications or whatever it needs to do. This can also be used to kind of run TAs next to SPs, and it can run kind of simultaneously. It also runs the whole Xtest suite like that. Well, this can, it can run a standalone S-EL0 SBMC, or we can also run it under Hafnium as a secure under a secure hypervisor. This wasn't developed by myself, but this was developed by Jens, Mark, and Achin. So next slide, please. So we have a proof of concept at the moment. The link is there. Most of our code is being pushed to the PSA development branch. There is a fair amount of stuff supported already of the FF-A spec. We can handle the manifest file. We can communicate between secure partitions and the normal world via the direct request and the direct response messages. The RX-TX buffer management is implemented. The endpoint ID is implemented. We can do some basic memory region mapping so that we can share data between the secure partitions and also between the normal world and the secure partition. We have some device regions where we have some tests that we've done to map device regions. We have some code to have secure EL1 SPs, and we are especially looking into that for the RPMB, which is currently into development to support RPMB with secure partitions. And then we have some code for interrupts, and that's currently in review. Next slide, please. So we are planning to kind of upstream everything to GitHub. It does take a little bit longer to get everything there, so it's kind of a step-by-step approach. But on the long run, ideally, we want to kind of just get everything into GitHub. So it's the standard Opti GitHub repository. And at the moment, we have some basic functionality already there upstream, so we can load and we can run the SPs. We can handle the direct request and the direct response message, so you can send messages from the normal world to secure partition and between secure partitions. And then the RX-TX buffer management is currently in review, and that should be hopefully merged fairly soon, and then I will start pushing more batches from once that's done. Yeah, next slide, please. Yeah, so if you need any more information about this, you can always kind of send a mail to the mailing list. Everybody on our team reads the mailing list, and then we can definitely respond to that. And then I also added some kind of presentations, some other presentations that are where FF-A comes into play, because it's a big topic for ARM now, and we want to support it as much as we can. Yeah, I think this was my last slide. Sorry for the technical difficulties, but I'm happy that I managed to get through it. So I hope it was an interesting talk, and I don't know if there's, let me see if I can check.
There are a couple of questions. It looks like one has already been answered, but there's another one that you should see in the Q&A tab. So does SP support preemption from normal world interrupts like we have for TAs?
That's a good question. I would have to check it. I mean, the interrupts, it's in an early stage yet, but normally it does. So there is a patch that we also do, that we are kind of changing for the trusted firmware that we need first, where then we can, for the SBMD to be able to forward these interrupts to the SBMC. So it should, in the long run, but we might need a little bit more work on that.
Okay, and the other question was, can TAs and SPs exist together? But it looks like this has been answered. Yes, they can. Do you want to add anything to that? Or?
No, so the thing is they can. So the only thing there is that for the Opti specific calls will be wrapped into FF-A messages, and then the Opti kernel will kind of handle those as an endpoint, and then we'll translate them and then pass them to TAs if needed. So yeah, they can.
Okay, and I think that's all the questions. So anything else?
Yeah, no, not from me. So thanks everybody from joining. And yeah, if you have any questions, just send the mail to the mailing list, and then we will definitely answer it.